Welcome back, and we are doing the John Lemon uh, beginner course on learn.unity.com, and we're doing the player character part 2, which we're uh, actually adding some script for movement, and I'm in the middle of this part. And the last deal we did was add the uh, we called set bool is walking to is walking. So whenever is walking is true, then it will set uh, the is walking parameter uh, in the um, in the character dealie. In essentially, this is walking is just code. It's local to the player movement script, and this is walking is actually the property of the character. So that's what it's doing. The code is calling the set bool method using the animator component reference you just set up. The first parameter is the name of the animator parameter that you want to set the value of. The second is the value you want to set it to. It's important to get the spelling and capitalization of the first parameter absolutely correct, otherwise the method won't know which animator parameter to set the value of. The script should now look like this. Now, one thing I should probably do is I should check to see if I guess the prefabs. Is it in the prefabs? John Lemon prefab. Okay. So does it have? I'm not sure where that's at though. Is walking. Maybe that's not in here. Maybe that's actually in the. Let's go back to scenes. Maybe that's in John Lemon himself here. I don't remember. Where did we add that? That property. We did that in what? The animation controller. So let's try animation, animators, the John Lemon animation controller. Here. I'll expand this out just so I can see it. Open, of course, that's why oh. There we go. I'm not sure what but where did oh, is walking is right here. Okay. So it is capitalized correctly. That's really all I wanted to know. That's why I did this. So okay. Let's go back to this. Script should now look like this, which it does. That's it. You set the value of the animator parameter. Or it gets completed. So we completed that step. Create rotation for your character. Let's look at the next job that needs to be completed every frame, creating a rotation for your character. In this game, the character should only be able to walk forward, so it needs to face in the same direction as the movement. However, if John Lemon flips quickly to the desired direction, it's going to look really weird, so you need to slow it down a little bit. But just how much do you slow it down? A slightly easier way to frame the question is considering how fast the character should turn. To set the speed, you need to create a new variable. Add the following to the top of the class above the animator member variable. Okay, so save this. Above the animator member. Okay. Public float turn speed semicolon. Save. Let's explore this code. You've added the word public before the variable declaration. In Unity, public member variables appear in the inspector window and can therefore be tweaked. You've also used camel case rather than Pascal case with its M underscore prefix. This is because the variable is public, and the Unity naming convention uses this format for public member variables. Naming conventions can be very useful, and there's no technical reason for doing this. Pardon me while I do that. Okay. Calculate your character's forward vector. Remember, you need the character to face its direction of movement. All transform components have a forward vector, and so a good intermediary step would be to calculate what you want the character's forward vector to be. Add the following line to the bottom of the update method. Alrighty. Vector 3 desired forward equals, and I'm going to go ahead and it'll indent it for me. Vector 3 dot rotate towards what? Transform dot forward, comma, m movement, comma, turn speed times time dot delta time, comma, 0f. Okay. I don't know if this lets you do it, but this is kind of how I would do things sometimes. And maybe it'll complain to me later. It shouldn't matter in C#, whether it's on a different line or not, partly because there's a semicolon here. And so that's not for strings. Putting strings on a different line is something completely different. I don't even know if they do those anymore or what. But I have decided that I just want to do this so that it's actually in my screen here. And actually, I could just, yeah, do that. All right. So, we got that. It's quite a long, complicated looking line of code, but it includes lots of similar things. Let's break it down. The code creates a vector 3 variable called desired forward. It sets it to the return of a method called rotate towards, which is a static method from the vector 3 class. Rotate towards takes 4 parameters. The first 2 are vectors 3's, and the vectors that are being rotated from and towards, respectively. The code starts with a transform forward and aims for the m movement variable. Transform forward is a shortcut to access the transform component and get its forward vector. The next 2 parameters are the amount of change between the starting vector and the target vector. The first, the change in angle in radians, and then the change in magnitude. This code changes the angle by turn speed times delta time and magnitude by 0. Time.delta time is the time since the previous frame. You can also think of it as time between frames. So why do you need to multiply the turn speed by that? Update is called every frame, and if your game is running at 60 frames per second, that means this method would be called 60 times a second. There would be a very small change in each call, so that over 60 frames you get the change you want for a second. But what about a game running at 30 frames per second? Only half the method calls will have been made in the same time, and only half the turn will have been happened. You don't want the number of frames per second affecting how fast your character turns. That's not good. So what about if instead of making the change per frame, you were dealing with the change per second? That would make things a lot easier. To do this, you need to multiply whatever change you want per second by the amount of time that a frame took, and this is exactly what this code does. Okay, let's mark this as completed. Okay, adjust the turn speed variable. The turn speed variable is the angle in radians you want the character to turn per second. This is multiplied by time.delta time to get the amount the character should turn this frame. Radians are a different measurement of angle. They are similar to degrees, but they're more natural measurement. A circle has 2 pi radians in it, so approximately 6. Your character is always going to take the shortest turn, so the most the character will ever turn is about 3 radians. Given that a turn speed of 3 would mean it takes us about a second for your character to completely turn around. This is actually quite slow. Turn speed of 6 would mean it takes around half a second to turn around, which is still quite slow. Let's try a value of 20 and see what it feels like. You can always change this later if you want to. Change the line declaring the turn speed variable at the top of the class to turn speed equals 20f. So public flows turn speed equals 20f. Now we have a vector for the direction you want your character to face. Create and store a rotation. Next, you need to use the vector to get a rotation and store it so that you can use it wherever you want. You're going to store it like you did the movement vector, so it makes sense to declare its variable there. Below the line declaring the vector 3 called m underscore movement, add the following line. Okay. Quaternion m rotation equals Quaternion dot identity. And I really have almost no idea what quaternions are. Some sort of 3D math thing, and I don't really know what it is, but probably don't need that to understand how to use this. Okay. Quaternions are a way of storing rotations. They get around some of the problems with storing rotations as a 3D vector. This tutorial doesn't explore them in detail. Knowing that they are a way of storing rotations is all you need to know. You've given the quaternion a default value of quaternion identity. Normally, variables are part of the class member variables rather than specific part of a specific method. Are set to their default value when the instance of the class is created. For example, vector 3's default value is to have x, y, and z all set to 0. The same is true for a quaternion. However, while a 0 vector makes sense as in no movement, a 0 quaternion doesn't make much sense. Setting the value of quaternion that identity is giving it a value of no rotation, which is a more sensible default. Now that you have created a rotation variable, you can set it below. You can set it below the desired forward variable declaration at the following line. Right. So before that, or underneath that, m rotation equals quad dot look rotation desired forward. Okay. The line simply calls look rotation method and creates a rotation looking in the direction of the given parameter. Description now look like this, and we'll do this. Description now look like this. Player movement turns to be 20F, quaternion up there, and animator get component, horizontal, vertical, right. Math F, we've already done that. Vector 3 desired forward, and then M rotation quaternion. Okay, so it does look like that. So that's good. And we have now reached the end of this particular video. I'm going over time a little bit, but that's okay. So thanks for watching. I will see you in the next video.